Greetings and welcome, friends. Yesterday we talked about the fact that you can prove two triangles are similar with simply two angles corresponding between the triangles being congruent. It turns out side similarity theorem. Look at how many S's that is. SSS. So great. Is also sufficient to prove triangles congruent. So if the corresponding lengths of the sides of two triangles are proportional, of the two triangles are proportional. So all three sides are, then the triangles are similar. So that would be like this is proportional to that, as this is to that, as this is to that, right? So it turns out if you have that, then that is sufficient to prove the triangles are similar. All right, so we have to actually prove these ratios consistent for all of them. And if they are, that's also going to be our scale factor if it goes from new to old. All right, let's see. Are any of these triangles similar? Oh, cool. They were kind enough to, like, color coordinate for us. That was sweet of them. No, on yours, you have black and white. But either way, let's compare... All right, so I'll do 6 is to 8 as 9 is to 12 as 12 is to 16. And then let's reduce these. 3/4. Divide by 3, 3/4. Divide by 4, 3/4. That means these two triangles are similar. How about this one to that one? Oh, right, because those are exactly the same. So 16 over 16, the ratio is 1, the scale factor is 1, so that means everything should be identical. But notice that, yeah, it is not. Good call, good call. So this is not equal, and therefore these two are not similar. And then I think by some sort of transitivity, if these two are similar and this one's not similar to that, then this one's not similar by transitivity of similarity. I don't know. I just made that one up. That sounds good, though. Not similar. There we go. Actually, wait a minute. That's crazy. Back when we were doing logic, this meant not P, but now it means similar, and I just wrote not similar, which means not. I'm sorry. I'm just terribly... I don't know. Either way, I'm amused. That's all that matters. Which is my primary goal every day of my life. Half of the jokes I say, nay, all of the jokes I say are for my own entertainment and not my listeners, the people in the room with me at the time. All right, here's a side question. All right. Oh, I think this is too big of a question right now. But one thing I will say on the mic is that if your goal is to succeed 100% of the time in life, the only way you can do that is to aim for failure and do it. Because aiming for success, you're not going to succeed all the time. But if you define success as failure, that's something that's achievable. And you could do it all of the time. If your goal is success 100% of the time. All right, so let's see. Find the value of x that makes these triangles similar. All right, so 4 is to 12 as x minus 1 is to 18. And then we'll also have to verify that that scale factor works for these sides once it's determined. Let's reduce that fraction first. I think Jordan agrees. Yep, he does. 4 goes into 4 once and into 12 thrice. And then I can cross multiply. So I'm going to have 3 times, parentheses, x minus 1 is equal to 1 times 18. So 3x minus 3 equals 18. Yeah, I think so. So 3x equals 21, and then div 3. And I get x equals 7. And let's just verify, is 3... Oh, I have to put 8 over it. I did a little over big in this case. 8 over 3 parentheses 7 plus 1. Is this ratio the same as 4/12 or 1/3? Oh, because this is 8 and this is 8.